Welcome. We're going to start by making a hypothesis about a shape. So let's see what this thing is. 2, 4, 6, 8, 10. So negative 10, 4. Negative 2, 10. 4, 2. Negative 4, negative 4. Okay. So here it is. It would probably be smart, although I can't do it and hold on a bit, to use something pretty straight to trace this. I'm just gonna okay. So I'm thinking it's a quad, definitely, right? 4 points, 4 sides. I'm thinking maybe a square. I'm kind of leaning toward a square because if I tilt it, it's looking like a square. Also leaning toward a parallelogram because these things look like they're going in the same slope. Kind of ruling out a trapezoid or a kite. So let's see what this is. The first thing I have to do is classify the shape. So I actually think it's a square, and then there's a couple ways we could prove that, but that's my guess. Now to clarify that, I think to be a square, we defined in class that all of these sides have to be equal, and all of these angles would have to be equal to 90. So I think I could start here, the length of each side, and it doesn't matter what order, the length of this side. Well, if I calculated the slope, which I could, it looks like IJ, so the slope of IJ, it looks like it's going uphill, right? Up as I go from I to J. So that's gonna be rise over run. Now I'm gonna count how much I rise. 1, 2, 3, 4, 5, 6. And I run 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my slope then would be 3/4. Now the reason why this goes into the length is that just to make this shape, notice I went up 6 over 8. And that's going to tell me the length of this side as well. So it's like I went through the trouble of going up and over to find the slope, but I actually can use that information to draw an imaginary right triangle and then use Pythagorean theorem to solve for that missing side. So I have 6 squared plus 8 squared, and I'm noticing that this is a pattern I recognize. I get a square root of 100, and then that's 10. Okay, so the length of this side is 10. And my hypothesis is that that's 10, and actually that might be 10, and that might also be 10. But let's confirm just this side if, in fact, it has the same slope and the same length. So I'm going to do the same thing. Instead of doing the slope of IJ, I'm going to do the slope of LK. So when I do the slope of LK, I start here, and I do the same thing. I count up and over. So I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so same thing. The slope of LK is rise over run, which means all I've proven is that they have the same slope, which this would lend itself to being maybe a parallelogram if I can then confirm these are same slopes. So, but I don't know if you picked up on it, but notice I went up 6 over 8 a second time. So that's proof that if this is true, then in fact, this would also be 10 for the same reason. So this is the length of line IJ, and it's the length of LK. Now let's do the same for the other sides. So I have IL, which is actually going down. So the slope of IL is falling over run, and I'm just going to count how much I fall. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So I fell 8, I ran 6, And I like the looks of this because this is looking like the opposite reciprocal. So what I've just confirmed right now, since that is the opposite reciprocal, is that that is perpendicular. So what I can do now is actually make a box right there. I've confirmed that the slope of this line is the opposite reciprocal of that line. I also did something interesting as well. I saved myself the trouble because I'm drawing another triangle, down 8 over 6. It's the same as this one, except if I tip my head. So down 8 over 6. The hypotenuse should again be 10. And I'm almost about to prove this is a square. So let's just reconfirm. JK, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. There it is again, down 8 over 6. So the slope of JK is also -4/3. And it looks like all 4 lengths, not just IJ and LK, but the other 2 lengths, IL and JK, are all 10. So just knowing though that they're all equal length only means they're a rhombus, because by definition equal lengths is rhombus. So it's really these slopes. Notice how these 2 slopes are opposite reciprocals, these are opposite reciprocals. So it's definitely confirmation that all 4 angles are 90-degree angles, because all 4 of these angle relationships are opposite reciprocals. Okay? Cool. So I think that that's enough proof that it is a square, because all sides congruent and all angles congruent. Okay? So I think that now that I know it's a square, the area of a square is actually base times altitude, and I have a built-in altitude, so this is going to be an easy one. Just 10 times 10, or 100, is my area. And I don't know the units, so I'll just say units squared. Okay? Now for my perimeter, that's even easier. It's 10 and 10 and 10 and 10, or 40. Awesome. 40 units long is the perimeter. And this is 40 units squared. Cool. So to finish out the problem, even though I don't need these diagonals, it helps. What would have been another way to prove? Okay, so if I could extend this line and I extend that line, I get pretty close to looking like maybe somewhere around here is the center where those diagonals meet. So let's calculate that. One diagonal looks like IK, correct? So if I look at diagonal IK, I can look at point I and I can look at point K. And I can use the midpoint formula, or I can just use kind of my observations of finding the middle coordinate to see what that middle coordinate would be in IK. So the 2 x values, if I add them, and the 2 y values, and add them, and then divide by 2. Okay, so I get a midpoint here of what looks like -3 and +3. So when I go back over here to reconfirm what I've found, I go -3, +3, and I like it. I'm just going to call that M for middle. And I can do that a second time. Instead of using the diagonal for IK and reconfirming it's the midpoint, I could do JL. So JL is the other midpoint. And here's those 2 points, the other diagonal, JL. And I could reconfirm. So if I added those 2 values and divided by 2, I get -6 over 2 again. And if I add these 2 values, 10 and -4, I get 6/2. So once again, both times I would reduce to the same coordinate. And that's another way to prove to myself that that theorem is correct. When the diagonals meet, they bisect, meaning this length is equal to this length and this length is equal to this length. Okay, So now let's find the length of diagonal, because we actually know that, I'm just going to draw a little version of a square off to the side. We also know that the diagonals of a square are equal, because the square happens to be a rectangle. And so that's a feature that the square inherits from the rectangle. Let's confirm that using math. So if I want to find the slope of this diagonal, IK, once again, here's I, here's K, and that's the coordinates of the diagonal, IK. To find the slope, we could do, using the formula, we could do it, or we could just go from I to K and do rise over run. The problem is it looks like it's going down. So I think that the slope of IK would be fall over run. So when I go from I to K, I kind of have to straighten this out here. It looks like I go down 2, so I fall 2. And then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Interesting, okay? So 1/7. Now I'm going to find the slope of JL. So just to rewrite, I like to kind of rewrite the coordinate if I need to use it later. Actually, I'm not going to use it, so I guess that's a little bit of a waste of time, but I'll do it anyway. If you want to use the formula, that's a really smart way is to recopy it. Okay, so the slope of JL, it looks like it's going uphill, doesn't it? So I'm going to write rise over run, and I'm going to find out how much I rise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I run 2. So looky there. Those are opposite reciprocals. So what that means is they are perpendicular. For sure. And so that's something that the square, that's an attribute that the square gets from a rhombus. So because all 4 sides are equal, these diagonals are not just going to meet in a midpoint, but they're going to meet at a 90-degree angle, and we've reconfirmed that. So that's really cool. Last, I'm going to find the length of those diagonals. I mentioned that earlier. That's something special to a rectangle. So notice we went down 2 and over 14. So you can think of that as a rectangle. The 2 and the 14 are the lengths of the 2 smaller sides, and the length of the hypotenuse would be 2 squared plus 14 squared. So that would be the square root of 4 plus 196. And when we add 196 to 4, we get the square root of 200. And that's about 14.14. So that sounds about right. If you don't have a calculator, just leave it the square root of 200. So that's the length of this one. And notice this one went the same dimensions, up 14 over 2. So it would be this same triangle, 14 and 2. And so both of the diagonals, IK and JL, are equal to the length, the square root of 200. And that's it. Congratulations. Have a great long weekend.